Here we have section A, data cleaning. When merging data sets with different measurement system, ensuring compatibility between units is crucial. In data clearing, garbage in, garbage out stresses that analysis quality depends on input data. Artifacts are systematic problems introduced during the data cleaning process that can be corrected. Irrecoverable information lost during acquisition is an error. Replacing missing data with the mean of existing values is called mean imputation. Filing missing values via linear regression or curve fitting is known as interpolation. Always preserve both the raw data and the cleaned dataset. Converting John Smith to Smith John is an example of compatibility. Outlier detection is often used as a sanity check. Functions like Unidecode help remove inconsistent characters during miscellaneous repair. Section B, Machine Learning Concepts. Transforming new variables into more informative ones is called feature engineering. Predicting a numeric values such as salary is an example of regression. A model that fits training data perfectly but fails on new data suffers from overfitting. Dropout and weight penalties are examples of regularization methods. Training multiple diverse models to improve accuracy is known as ensemble learning. A simple reference model for comparison is called a baseline model. Independent, unchanging data samples are described as static data. Parameters tuned before training are called hyperparameters. Comparing two versions statistically to see which perform better is A divided by B testing. Normalization typically rescales numeric features to a range 0 to 1. The difference between the train and the test performance measure model generalization. Biased sampling in data collection can cause selection bias. A model trained once and not updated further is a static model. A model that continually retrained with new data is a dynamic model. The loss function measuring divergence between predicted and true probabilities is logistic regression. Section C, Deep Learning. Deep learning is a specialized subset of machine learning. Neural networks are universal approximators of functions. A network with more than one hidden layer is termed as deep NN. Each layer output becomes the next layer input. CNN are mainly used for image classification. RNN handles data with strong sequential dependencies. LSTM is an improved version of RNN network. In a GAN, the second model acts as a discriminator distinguishing real and fake data. Reusing a pre-trained model for a related task is called transfer learning. The wide part of the wide and deep model helps memorizing specific learning. The deep part captures more high-level features. Linear classifiers combine input with wide and deep to form predictions. Activation functions introduce non-linearity into neural models. Adding neurons or hidden layers increases model complexity. Transfer learning leverages learned features learned from prior tasks. Section D, Python data structures. Lists are ordered and mutable, meaning they can be changed. Tuples differ from lists because they are immutable. Dictionaries store data as key value pairs. Set contains only unique elements. A DQ allows fast operation at both ends. Counter is a subclass of dictionary that tallies occurrences. A frozen set is a set that is immutable. The heap queue module implements a priority queue. In a max heap, each parent node value is greater than its children's. Converting a list into heap order is called heapify.